Today we're going to be talking about simplifying radical expressions, and this is really important. We do this a lot throughout all of mathematics. I currently teach geometry, and I expect my students walking into my geometry class to be able to know how to do this. So, a key product property. So, if you have two radicals, you can split them up. So meaning I could split this up into root 4 times root 9, which they do over here, root 4 times root 9. And I take the square root of that, which is 2. Square root of 9 is 3. We know 4 times 9 is 36. Square root of 36 is 6. I can also break that up, and so that we get 6 being our answer for that. And hopefully this is going to make sense in a few minutes here. Okay, so splitting up these radicals. So, what you want to look at is you want to try and break 52, radical 52, up into a perfect square times by another number. And it's always best to try and pick your biggest perfect square. But when I see 52, I think it's an even number. I'm going to try 4 first. And that's what I was doing. I did 4 times 13. So I can split that up into square root of 4 times square root of 13. Square root of 4 is 2. Square root of 13, there's no other perfect squares in there. So we write it like that. Root 45. Try and come up with a perfect square that goes into 45. Hopefully you should see one right away. 9 times 5. So then I have this square root of 9 times the square root of 5. Root 9 is 3. Any perfect square we break out of that radical goes in front, and then we have that times root 5. Okay, so a couple ways we could do these problems. I was trying to decide how I was going to make you guys do this. Okay, so what I'm going to do is I'm going to multiply 2 times 24. But I'm not actually going to multiply it. Okay? What I'm going to do now is I'm going to break 24 up. Okay? 24 into perfect squares. So 24 is 6 times 4. I'm going to write it a different way. Is 4 times 6. And I still have that 2 in there. So 4 is a perfect square. So I'm going to write that there. I have 2 times 6. So I have 2 times 6 can be broken up into 2 times 3. So what do I really have here? I have 4. 2 times 2. Well, that's 4 times by a 3. So one of these 4s breaks out and becomes a 2. The other one breaks out, becomes a 2, and then we have root 3. Now multiply the numbers outside together to get 4 root 3. Doing the same thing over here. I'm going to do this other one a little differently. Because there's so many ways you can approach these problems. I just want to give you guys all of the possible ways. So I have root 5. 35 can break up into 5 times 7. Okay, which is really root 5 times root 5 times root 7. Now if you see two numbers that are the same, that can become root 5 squared. 5 squared was really 25, but that can break out of my radical and become a 5 root 7 outside. So 2 different ways to approach the problem. There's a couple other ways you could approach it. Okay, this guy. What you want to do is you want to start breaking everything up. So break up that, I'm going to start it up over here. Break up the 45 into perfect squares. So 45, 9 times 5. Now I'm going to break up this a to the fourth. A to the fourth is a squared times by a squared. Because if I were to add those exponents together, I would get a to the fourth. B to the fifth. Well, that's b squared, 1, 2, 3, 4, and b to the first. And then c to the sixth. I didn't want to do red. I want to do a different color. C to the sixth is c squared times c squared times c squared. Now you want to make sure your exponents add up to the exponent in the original. So what you now need to do is you now need to square root of 9. Well, that's 3. That's outside. I still have a 5 left over underneath my radical. For my a's, I have 2 of them that break out. So one of them becomes an a out front, another one becomes an a out front, so I have an a squared out front. For my b's, I have 1, 2, but this b can't be breaking out because he doesn't have a squared power, so that b gets left like that. For the c's, I have 1, 2, 3 of them to the second power, so I just c to the third out front. So that's how we would do that. Okay, now when we're dividing, as mathematicians, we don't like radicals in the denominator. So we want to, what I say, simplify, put it in simplest radical form, which means rationalize the denominator. I'll write that out for you. Okay, which means multiply by root 8 over root 8. So then that becomes, on the bottom, I have root 64. On the top, I multiply the 3 times the 8, and I get, I don't know why I had to do that in my calculator, 24n. I just didn't want to make a mistake. Okay, so from here, root 64 is 8. 24 can be broken up into 4 times 6 times n. That 4 can come out and become a 2 out front. Now, only things that have broken out of that radical. Okay, look at that radical like a house. It's a house. It's housed. You can't simplify anything on the top and bottom unless it's outside of the radical. So that 2 can cancel and become a 4 with the 8. Now I can't cancel anything with the 4 and the 6 because that 6 is locked in his house still. Okay. And our last one. Again, there's a radical in the denominator here. And I want to talk to you guys about conjugates. I think I spelled that wrong. So the conjugate of 4 minus root 5 is 4 plus root 5. So if you see something like this where you have a 4 minus root 5, you want to multiply by the conjugate. So let's just multiply those two things together. And I'm going to do the work over here since I already have it written over here. When you're multiplying two radicals like this, you want to do FOIL. So first terms, we get 16. outer terms. Inner terms. And then the last terms. That turns into a minus root 5 times root 5 is 5. Notice what happens here. Those cancel. That's what makes this so nice. And we get a nice 11 on the bottom. On the top, I'm still left with this. Now you want to distribute the 2 into everybody. And we get that as our answer. And that is my video on simplifying radicals.